Now we try to complete the techniques of integration of trigonometric function. Today we try to integrate integration tan to the power m x sec or nx dx. And the first case is when n is even. N here is even number. And not care about m. M may be odd or even. M here, even or odd. The first example, sine squared x over cosine squared x over cosine power 6x dx. In this case, we try to convert this formula or this form to this form, to tan and sec. So we divide the numerator and denominator by cosine squared theta. So sine squared theta, sine squared x over cosine squared x, cosine power 6x over cosine squared x dx. This equals tan squared x, sine squared over cosine squared equal tan squared, over cosine power 4x dx. This equals integration tan squared x cosine power 4x dx. Cosine here equals sec. Cosine is the denominator, becomes sec power 4x dx. So m here equals 2 and n equals 4. In this case, we substitute u equals tan x. So here we put u equals tan x, and du here equals, as we know, 6 squared x dx. So we need 6 squared here. So we separate this integration, tan squared x, sec power 4, we make it 6 squared x, 6 squared x dx. And we integrate by this substitution. This equals integration tan squared x, and we convert this to tan. Remember, we take the identity sine squared x plus cosine squared x equals 1. So if we divide both sides by cosine squared x, we get tan squared x plus 1 equals 6 squared x. So we convert 6 squared to tan squared. As we see, 6 squared x equal tan squared x plus 1, 6 squared x dx. And we substitute tan squared equals u squared, u equals tan x. So tan squared equals u squared, and tan squared u squared plus 1, 6 squared dx, x dx equals du. This integration equals integration u squared times u squared equals u power 4 plus u squared du. by integration u power 4 equals u power 5 over 5 plus u power 3 over 3 plus c. We put tan x instead of u tan power 5x over 5 plus tan power 3x over 3 plus c. This is the value of integration. Now another example. Integration sin x over cosine power 5x dx. We divide the numerator and denominator by cosine x. We get integration sin x over cosine x in the numerator, and in the denominator cosine power 5x over cosine x dx. This is equal integration tan x over cosine power 4x dx equals integration tan x sec power 4x. So tan here to the power 1 is odd. In the previous example, we take m is even, here m is odd. And n here in the first example and this example equals 4 even number. We take u equals tan x, u equals tan x, and u equals 6 squared x dx. So we need here 6 squared x, tan x, 6 power 4x, 6 squared x, and we take 6 squared x dx to make the u. This equals integration tan x, 6 squared x, as we know, equals tan squared x plus 1, 6 squared x dx. This equals tan x equals u, tan squared plus 1 equals u squared plus 1, 6 squared x dx equals u, and integrate u power 3 equals u power 4 over 4, u power 1 equals u squared over 2, and plus c. We put tan x instead of u, tan power 4x over 4 plus tan squared x over 2 plus c. This is the value of integration. The second case, n and m are odd. So here n is odd and m is odd. For example, integration tan power 3 x sec x dx, sec power 1, tan power 3, both are odd. In this case, we make this substitution u equals sec x, and du here equal 6 squared sec x tan x dx. So this integration equals, we need sec tan, sec here, and we need tan from this tan power 3. The rest here, tan squared x, tan x, sec x, tan from tan power 3 dx. Tan squared equals 6 squared x minus 1, because the previous and the identity we take tan x sec x dx. this equals u equals sec x integration of u squared minus 1 10x sec x du. This is equals u power 3 over 3 minus u plus c equals u power 3 equals sec power 3 x over 3 minus sec x plus c. This is the value of integration. Now we take a very difficult case. If m equals 0 and n is odd. In this case, if n equal 2r plus 1, r belongs to natural number n. So we take integration sec power n x dx equals integration sec power 2r plus 1 x dx equals, we take sec power 2 here x dx, and here 2r minus 1, 2r plus 1 minus 2 equals 2r minus 1, and complete by parts. As example, if we want to find I equals integration sec power 3 x dx, we make it integration sec and sec squared x dx by the rule, and we take this sec squared x dx equals dv. dv equal sec squared x dx, and u equals sec x, because we can find v from dv by integrate sec squared. v equals 10x, and we can find du equals derivative of sec equals sec tan, sec x tan x dx. So I equals integration sec power 3x dx equals uv sec x tan x minus integration u dv v du. Integration v du here equals sec x tan squared x dx, tan squared x dx. Integration sec power 3x dx equals sec x tan x minus this integration. We can substitute tan squared equals sec squared x minus 1 dx from the identity. This equals sec x tan x minus integration of sec power 3x plus dx plus integration sec x dx. The product here negative, positive. This integration is the same integration of the left hand side. So we can switch it in this side, and we obtain 2 integration sec power 3x dx by adding integration sec power 3 here, positive, equals sec x tan x plus integration sec x dx. And we can find sec x by using sec x here and multiply by sec x plus tan x, and here sec x plus tan x in both sec x over 1 in both of numerator and denominator, we multiply by sec x tan x over dx. So this integration equals sec x tan x plus integration sec squared x plus sec x tan x over sec x plus tan x dx. We notice that the numerator is the derivative of the denominator, because sec, the derivative of sec equals sec tan, and derivative of tan equals sec squared. So this integration, 2 integration sec power 3x dx equals sec x tan x plus ln absolute of the denominator, sec x plus tan x plus c. This is the integration. If we divide by 2 here, half and half. Integration sec power 3 x equals half sec x tan x plus half ln sec absolute of sec x plus tan x plus c. Thank you.